just exactly 7:40, and I think we'll get started. Can everyone see the slide and hear me? Okay, good. There is a question, when is the quiz will start? I think we are going to go through chapter 7, and I am hoping that we will finish it today. And once we finish chapter 7, based upon how we're going, so my goal is to finish chapter 7 today. And after we finish chapter 7, we'll take a few minutes break, and then we'll have the quiz. So I'm guessing the quiz will start somewhere around 9, maybe a little bit earlier. And a couple of announcements I wanted to make. Two things. One is there was a question on what exactly is expected in the presentation, which is next Thursday, the last day of the class. I have posted in Desire to Learn the expectation on the presentation and what exactly I'm looking for. So go ahead and have a look at it, and if you have any questions, you can certainly call. Certainly, we can certainly talk about it in the next class or today after the break. But primarily, I'm looking for 10 to 15 slides, your problem statement, what problem you're trying to solve, a conceptual design, how a data model, a conceptual model that you came up with is going to support the business problem that you were, support solution of the business problem, a visual diagram of the entity relationship, the data model, a physical implementation of the data model in SQL Server, and approximately 15 queries that you run on SQL Server to store and retrieve data from this particular database. So that's the whole, the goal is that given a business problem after the conclusion of this class, you'll be able to create a data model, you'll be able to implement the data model in the database, and you'll be able to using SQL, you'll be able to store and retrieve information from the database to support a business problem. And again, I think this is, I had posted it on Desire to Learn as an announcement. So if once you look at it, if you have any questions, feel free to ask me, and I'll explain it more. Any other questions before we start? Okay, so here we will, in this class, I think, again, the class basically is following everything that you are going to do in the project. So we have gone through through logical design, we have talked about the database design, we have talked about SQL. Now we're saying, how do you use SQL to construct database, and how do we do application processing? So remember this view-raise gallery that we talked about. It's a small art gallery that has been in the business for 30 years. It sells contemporary European and North American fine art. View-raise has one owner, 3 salespeople, and 2 workers. View-raise owns all of its art that it sells, and it holds no items on consignment basis. These are the business problems. So that's the overview of the business. This is the business problem that we're trying to solve. Truck, customer, and when you're doing your, this is an example of what the project presentation should look like. So this is your overview of what the business problem is. or what is the something about the problem about the business. Then this is the application requirement. This is what we are trying to solve. Track customers and their artist needs, record gallery purchases, record customers' art purchases, list the artist and work that have been appeared in the gallery, report how fast an artist's work has sold and at what margin, show current inventory in a web page. So this will be the application requirement. This will be saying this is the business problem. The business problem is the business wants to track customers. The business problem is the business wants to record all the purchases that the gallery has. It wants to record all the art customers' art purchases. That who bought what from them. List all the artists and works that have appeared in the gallery, and report how fast the artist's work have sold and at what margin. So current inventory in a web page. And I think you probably remember this is, and again I'm not going to go in detail into this model, but this is the next step. Once you have the business overview, then you have the exact business problem that you are trying to solve. Then you have come to the conceptual design and the data model. So this is here I will be expecting you to have a video of the entity relationship diagram. So this is the entity relationship diagram. I think we talked about it in previous class, so I'm not going to go into detail, but this is what is one of the deliverables for your project. Okay. So once you have the entity relationship diagram, now how do we create physical implementation? And that in SQL Server. Whatever we see here is a logical or a conceptual design, and this is the physical design. And for the physical design that we talked about, there is some differences between logical and the physical design. After you have done the physical design, this is the implementation of the physical design in the database. We do that using SQL Data Definition Language, which is called a DDL. The DDLs have certain keywords, create table, alter table, drop table, and truncate table. So what are these does? Create table creates tables, alter create an existing table, drop a table, basically deletes an existing table, truncate a table. Again, I will go into detail of what a truncate is. That's a little higher concept, but I'll talk about it a little later. In the data manipulation language, once you have created these tables, once create, alter, and drop and truncate, you have insert, update, delete, and merge. And these are the data manipulation languages where you are inserting data into the table after it has been created, or updating the data in an existing table, or deleting data from existing table, or merging several tables together, two or more tables together. That's the reason it's called a data manipulation language, because in the data manipulation language, we are basically manipulating the data stored inside a particular table. So then there is concept of alternative joins, alternative joins, and we'll talk about that a little bit more. But just remember these top 8 things, that there are concepts called create table, and I'm sure if you are already working on the project, you are familiar with these concepts: create table, alter table, drop table, truncate table, insert, update, delete, and merge, and outer joins. Okay, create table statement is used for creating relations. Each column is described with 3 parts: column name, data type, and optional constraints. So this is an example of a SQL statement that you will write in SQL Server to create table. So here, again, as I was saying, this will be a great example of SQLs and queries that I must be asking to produce as part of the project. So it says create table artist. So here is we're creating a table called artist. Artist ID is int, not null, and its identity 1, 1. Okay, so it starts with a 1, and again, the book really gets into a lot of different concepts. Identity 1, 1, yeah, if you don't know it, I'm okay with that. Very rarely we use those concepts. But there are artist ID is integer and it's not null. Those are very important concepts. First name is character 25, not null. That means artist ID is required. Not null means you cannot have a blank or a space in the value. So that means it's a required field. Last name character 25, not null. That means it's a required field. First name character 25, not null. That means it's a required field. Whereas nationality, date of birth, date deceased, all can be null. That means you cannot have data on those particular fields. Constraint, artist primary key, artist TK, primary key artist ID, constraint artist AK1, unique last name and first name. Again, we'll get into this in a little bit detail, but if you are just for the time being, hold the thought on the constraints. We're going to talk about constraints a little bit more, but just realize that when you describe, when each column is described, you should have a column name, you should have a data type, and whether it is an optional constraint. So these are optional constraints. And here the constraint is that we have an artist, we have a primary key, key artist PK, which is based upon primary key artist ID. So, but again, this type of there are several variations of this, but you can say that to create a table, minimum you need is artist ID, integer, and you say whether it is these two are required. Anything else that you see is optional, because you cannot create a table without specifying the kind of data type, the name of the column and the data type, and everything else you see is optional. And the data types, I think we went through this previously, are binary, character, date time, in image, integer, money, numeric, small date time, small int, small money, text, tiny, varchar. And again, I honestly think that it's the difference between, I think, if you go into details of each of these, you figure out where integer is required, where a small integer is required. It all depends upon how much data, what is the biggest value of the data that you are going to store in that field. The whole idea is to be efficient so that you don't waste a lot of disk space. And again, remember that it is good to be efficient, because when you are storing literally millions and millions of transactions, or even billions of transactions, even small amount of waste can really balloon into humongous amount of disk space waste. And that's the reason it's very important to figure out, even if you can use an integer in place of a small integer, probably it's not the best design, because you are going to waste a lot of space. Similarly, you can use character and varchar you can swap between them, but the difference is character assigns fixed length. So if you say character 50, the database assigns 50. If you do varchar, what it does is it assigns value based upon how much you need, instead of arbitrarily assigning 50. So obviously varchar is more efficient than a character field. So when you are creating the database, you need to know what are the data types that you are going to use, and why those data types are best for the type of data that you are going to store. So if the data the data type is primarily based upon the type of data that you are expecting to store. You are expecting to, like, here is an example. let's say date of birth, it says numeric, but it is possible that date of birth may not be numeric. So you only know what kind of date of birth you are getting. Are you entering a numeric field, or are you entering classes between the month, year, and day, or you are writing 9th June 2013? Based upon that, this field will be different. So the design of the database, or how you create a table based upon the type of data that you are expecting. Okay, constraints can be defined within the create table statement, or they can be added to the table after it is created using the alter statement. So the constraint that we talked about is, as I said, you can either do it when you are creating the table, or you can do it with the alter table statement after the table has been created. There are 5 types of constraints that are primary key may not have null values. Unique may have null values. Not null. So foreign key and check. So these are the 5 types of constraints. So let's look at each of them. Let's see. I don't think I'm going to get through that. Okay. So here is a table, create table artist with not null identity. That means artist ID is increases by 1. It starts with 1 and increases by 1. And constraint is primary key is artist ID, and last name and first name is unique. So a combination of, you cannot have an artist with, so the constraints are basically saying that there are 2 constraints, artist PK and artist AK1. That first artist PK is nothing but a constraint which says that the primary key is artist ID. Similarly, the second one says the last name and first name has to be unique. And so you cannot store two artists with the same last name and first name. The system will reject it. So when you try to insert into the, even if you enter a different artist ID, first of all, what it says, the primary artist ID is artist ID. That basically means that you cannot enter an artist ID which already exists, because I guess artist ID is primary key and it will be unique. Similarly, this also says that the last name, you cannot have a last name and first name which is same. So you cannot insert that into the database. So this is again create table work. It starts with 500, increases by 1. Title, character 35, not now. Copy, character 12, not now. Medium, character 35, and can be now. And so here you see again. I think we cannot in this lecture we cannot exactly teach you every syntax that you can use. But the idea is to give the flavor of the thing. So when you are trying to use SQL Server to create these tables, you use some of it. And I'm not expecting that you will be an expert in every single nuances of SQL Server, and the idea is to just give you the flavors. But the basic things like, putting in a constraint, the data type, not now, you should be able to do that. Okay, so I'm not going to get into a lot of. Okay, let's look at some other constraints that they have done. In this one, they have added more constraint. Here it says constraint nationality value check nationality in Canadian, English, French, German, Mexican, Russian, Spanish, and United States. So you can create a constraint called nationality check values check nationality in Canadian, English, French, German, Mexican, Russian, Spanish, United States. So what does that mean? That means that you have a constraint, check constraint, that basic, and you can have nationality. The values which are acceptable are Canadian, English, French, German, Mexican, Russian, Spanish, and United States. So if you enter any value other than that, the SQL statement, your SQL insert statement will fail. Similarly, constraint birth value check date of birth less than date deceased. So if you enter, when you are trying to insert data into this table after you have created the table, so these constraints are enforced when you try to insert, update some information in the table. So when you create the table, it's like you are creating a template. So you say, okay, this is the template I'm going to follow. And so when you write these constraints, that basically tells the database that you cannot have, when you are entering and inserting or updating data in this particular table, this database validates these constraints for you before it stores those information. So that's the basic thing that a constraint does. So birth value check constraint is check date of birth less than date deceased. So you cannot have a date of deceased which is earlier than date born or date of birth. So that makes sense. So if you enter by mistake or intentionally a date of birth which is later than the date deceased, then it should give you an error message. Similarly, valid birth year. Valid check date of birth, like basically it says that it can be 1 or 2, 0 or 9, 0, 1, 0, 9. So the date of birth is a valid value from either 1 to whatever they're describing it, and it really doesn't matter, but basically it's saying that it can be either 1 or 2, it can be between 0 or 9, it can be between 0 or 9, and it can be, so date of birth will be 1 or 2, so it is either 19 or 20. So we are saying that the date of birth is either it's in, so this is 1, and this can be 9, this can be 0, it is between 1000, that's the earliest, or it can be as late as 2999. Okay? So those are the valid years. Similarly, the date deceased. Okay, let me ask this. Who is having any trouble following this? Or who is not getting it? And again, these. Yes, in the question is, it's not asking about your actual date of birth, it's asking for the year of birth. Yes, that's what it is doing. And again, this is the part that person designed. It's nothing. If you are doing the month, day, and year, and you might do 2-digit year instead of 4-digit year, that's perfectly fine. And that's the reason all the SQL, how you create the database, how you retrieve the database, all consists is based upon your assumption in the problem statement. So what exactly you assume. Okay. So after you created the table and you have assigned some constraints, create table is relatively simple statement, but after you have created the table and you have assigned you have assigned constraints to make sure that the table can only store values that that you expect it to be stored. There is data consistency and there is some validation. Once you have created a table, and as you know in business things change, and that means you probably did not think of something, you might want to add some new constraints. You might want to add some new columns. You might want to remove some columns. If you want to do that, then you do something called a alter table statement, changes the table structure, properties, or constraints after it has been created. So this one is just an example of a new constraint being added to the question is artist picker the name of the constraint or an entity? It's the name of a constraint. Like here, alter table assignment. So that altering the table is add a constraint called employee FK, foreign key employee number, references employee the employee table, employee number on update cascade on delete no action. So what is exactly saying is we are altering the table assignment, we are adding a new constraint, employee foreign key, employee FK, which is a foreign key on employee number, references employee table with employee number. Just ignore the on update cascade and on delete no action. That's kind of not important. But that's basically saying that we are adding a new constraint based upon employee number in the employee table, which is a foreign key to this particular assignment table. And again, most of the time we do not do alter to add constraints. Most of the time we do alter to adding and dropping columns. So this one is more prevalent and mostly used. So alter table customer add my column character 5 now. This is more how we do it. Alter table customer drop column my column. So these are the examples. These are the 3 examples. So if you think of 3 things we do, we alter table, we adding a column, altering table to remove a column, altering table in the previous example to add a foreign key constraint. So those are the 3 kinds of altering table. These 2 are very widely used. Constraints, rarely. So if you know these things, that's what I'm looking for. If you can do a constraint, great. But these are basic things that you need to know. That you can alter a table after the table structure has been created. You can add a new column, or after the table structure has been created, you can drop a new column. And that's what most of the time we use. Remember that all the constraints and all the things, extra things that the database does, adding a constraint and all that, in real world, in a programming, when you have ability to write code, you probably can do those in other ways, and database is not the best way to do it. But if you don't know how to write software, then probably that's the best way to do it, is through constraints. But you can do the same constraint through your C# or VB.NET or whatever programming language you are using. But you cannot do that. You create tables for changing tables and altering tables. The only way to do that is through the alter statement. Okay, this is another example. Alter table can be used to add a constraint as follows. Alter table customer, add constraint, my constraint, check, last name, not in Robert, no pay. So basically we are saying we are going to add a constraint called my constraint, that if we are getting a customer last name Robert, no pay, then if we are getting a customer whose name is Robert, no pay, you will not be able to enter the data into the table. So that's saying if it is not in customer Robert, no pay, then alter table can also be used to drop a constraint. alter table customer, drop constraint by constraint. SQL drop table. So we did the alter, we create, alter, now it's drop. If there are drop table trans, it's relatively simple. If you want to drop a table, you can just say drop table. And what does it do? It removes the table structure and the content of the table. So any data stored, in addition to the data, the structure of the table is also gone. Similarly, you can drop constraints also. Okay, so one of the concepts I didn't tell earlier was SQL truncate table. What exactly a SQL truncate does? SQL truncate table trans. When you truncate a table, it keeps the structure of the table but removes all the data that is in the table. So this is the difference between drop and truncate. Dropping the table removes the structure of the table and the data in the table. Truncate the table removes the data in the table but keeps the structure of the table intact. Cannot be used with a table that is referenced by a foreign key constant. We cannot do that because if it is referenced by a foreign key constant, then the foreign key, the other table is looking for this data to be in this particular table, and you cannot delete all the content because the content of this key of this table is the foreign key to another table which exists, and so you get an error. First, you remove the foreign key. If you have to drop this table, you have to remove the foreign key constant. Then you can truncate the table. But you cannot truncate the table when the foreign key relationship is still constraint is still available. Okay. Everybody following me? Okay, great. SQL insert statement. I think we have talked about this a little bit before, but this is SQL into artist, last name, first name, nationality, date of birth, values, and then you have the values like you're seeing it here. Similarly, if you are, this is something called a bulk insert. You could insert into a table the columns that you're mentioning, insert into artist, last name, first name, nationality, date of birth. Select last name, first name, nationality, date of birth from imported artist. What this does is, this block in the SQL statement in the first one, you're inserting one record at a time. In the insert statement here, you are inserting everything that is there in imported artist into artist. Everything that was there, so if imported artist contains 1,000 records, artist will have 1,000 records. If imported artist costs 1,000,000 rows, the artist will have 1,000,000 rows. And this is a way, instead of writing one SQL statement at a time, we can copy, we can bulk insert values from one table into another table. Everybody getting the bulk insert thing? So the insert into the same format, like the top one. But here we're saying select, again, the number of columns here and here has to be the same because you're selecting some data. So here 1, 2, 3, 4, here 1, 2, 3, 4, and you say select this, and he says insert into, selecting this, and here it goes. So this the order of this. So last name will go to last name, first name will go to first name, nationality will go to nationality, date of birth will go to nationality. But really, remember, they don't have to be exactly the same name, same column name. This column name can be different as long as the value that are stored in this column will move to this column. It happens to be they are the same, but they necessarily doesn't have to be the same. You can call it L name, F name, and NATIOM, whatever, and DOB, and then got this data. So the column names doesn't have to be exactly the same, but the order that the column names are specified, that's the order it's going to get into the table. Okay, so there's a question. So select has to be the column names. Yes, because you cannot do the select unless those column names exist in that particular table. So these column names must exist in imported database table, imported artist table. But these two column names doesn't have to be matched. This must be here, this must be here. Whatever is in here will go here, whatever is in here will go here, whatever is in here will go here, whatever is in will go here. This is the SQL update. SQL customer, I think we know about the update. SQL customer set city equal to New York, where customer ID equal to 1000. This is the update statement. So we are taking some data and we are saying if for customer ID 1000, update the city to New York. So already the data is stored and we are doing the update. Update customer set area code equal to 333, where city equal to Denver. So for any customer whose city is Denver, change the area code to 333. Say the area code change from something else to 333, we can update it. So this can affect a number of customers. If in a customer there is 3,000 customers who are based in Denver, then it will update 3,000 records. If there are 2,000, it will 2,000, 500. So this is the bulk update. This one is only doing for one customer. Customer ID equal to 1,000. SQL delete. Delete from customer where customer ID equal to 1,000. So delete is another SQL. So when you are saying delete from customer where customer ID equal to 1,000, that means the record, the row that has customer ID 1,000 will be deleted from the table, from customer table. Remember, if you omit the where clause, when you say delete from customer, it will delete every record that the customer has. Okay, so it will be a blank table. Okay. I think we have talked about join. I think you guys are doing pretty well. I don't really want to confuse introducing a lot more complex joins as the book does. So I will kind of skip that. But here is the LDS, which is very important, and I think it's easy to pick it up. Instead of writing, especially when the column and the table names are big, instead of when you're writing SQL statements, instead of writing column names, you can use table names, you can use aliases. So select c.name, comma a.name, where customer is C. So that basically means c.name is nothing but customer.name. So instead of writing customer all the time, customer.name, we are doing similarly. Here it says join artist as A. So when we say A, that we are basically saying artist. So that is how you are doing the aliases. That you can, when you are doing writing large SQL statements, you can use as a alias. You know, when you say customer as C, that means C is now associated with customer. Anytime we say C.name, it is customer.name. If you say C.customer ID, that means customer.customer ID. Yeah, similarly, customer artist int as CI. Again, alias is nothing but a short form of okay, let's see. I'm not going to get into that. Let's see. Okay. I'll get some better examples. I didn't like what the book has. I think next class I'll just talk about this outer joins a little bit, because I think it's important you know what outer join is and why outer joins are. But I think I don't like the book. I'll come up with a better example myself, and I'll talk about it in the next class. It will probably take 5 minutes, but let's do that. SQL views. A SQL view is a virtual table that is constructed from other tables or views. It has no data of its own, but obtains data from tables or other tables. So let me kind of give you an idea of what is a SQL view and why it is important. Let's say that you are working with your human resources system, or like something like SAP or PeopleSoft, or somewhere all the employee information are stored. And you are trying to build a database where you are trying to track employees' vacation and sick days and stuff like that, right? So for that, you need to have some information about the employees, who the employees are, which department they work on, how many years they have been working in the company, how many vacation days they get, stuff like that you need to have track of. But in addition to that information, in a human resources system, there are information regarding to for an employee, there is information related to their managers, their salary, their reviews, their promotions, all lots of information is available, right? But you don't need all those information. So what a database administrator can do is create a view from the original tables. So you got only the very few information that you need to track people's vacations. So that is called a view. In that, you don't copy data back and forth and create another set of tables, because it's redundant and it becomes very difficult to manage those. What we do is we create a view, and in the view is a subset of the data that is presented to the user, to the person who needs the view, or a DBA. And so view you can see is a slice of the data that is totally available without copying data back and forth to different tables. So you only go see what you need. That's the reason it's called a view, because it is a mob is put on top of the database to give you only the things that you need. And that's literally what a view is. A view is giving you subset of information without copying them into another table. A view may not include order by clause. SQL view is a subset of external views, and they can be used only for external views that involve one or multiple. Okay, so but you understand what the view is. So what I'm basically saying about the example that I gave, that it hides from you the information that you are not assigned to, or you don't have the privilege of seeing it. Instead of copying data between tables, it just gives you a limited access to the data, limited part of the data is just part of the view. We can hide columns and rows, display results of computations. It hides complicated SQL syntax, layer built-in functions. So you can do lots of stuff in a view, so that the end user doesn't have to do a lot of things. So if like a great example is airlines pricing. When you like, they always talk about that probably no single every single flyer in a particular flight paid different prices for the particular seat. Even on the coach, every single one in the coach paid probably different price. So how does that is done? Because these are done through complicated views to make sure that at a particular point in time, the price is based upon lots of other criteria, and you end user finds a different price. So basically the idea is that you can hide a lot of complexity behind the database, and only can show the user what they're looking to do. Here is an example of how a view. I'm never going to ask you how to write a view. This is probably beyond this the class that we are in. But you want to know that in real life, views are used widely, because in a complex database systems like a human resources system where there are thousands and thousands of tables, it is very critical that different group of people, whether they are working on different projects, get access to different sets of information without copying that information to different sets of tables again and again and again. So that's the reason. So I will stop on the view on that. I'm not going to ask you to write views. Embed SQL in the program code. And again, one of the things I have talked about is that some of the concepts we have learned in this class is is how to be self-sufficient in doing a lot of stuff in SQL itself without writing a programming language. But in real life, you can do some, if you are in accounting, or if you are a power user, or you are a business development person, you probably can get away with doing lots of stuff in SQL, but it is not a very flexible language, and to do things which are extremely flexible, you probably will end up using some kind of a programming language. And to do that, you have to embed the programming language inside the SQL, inside a programming language. And one of the concepts that we talked about is a SQL cursor, and this cursor are used to select one row at a time from a pseudo file. I don't know whether that's important, but okay. Well, we're talking about cursor a little bit, and I'll just give you what a cursor is. So if you are writing code in a program, and you write a select statement, and select statement returns multiple rows, and you want to get each of the rows and do something with it, then you put it in a cursor, and then you go in and read the cursor and get one at a time. So that's pretty much as much as you would like to know about cursors. Stored procedures. Okay, we'll also give you the concept of what a stored procedure is. A stored procedure is something that you can write in SQL that is executed at the server itself. So if you have written something and you are running it in the SQL Server database itself without without executing it from the command line. And stored procedures are done for multiple reasons. One of the primary reasons we do stored procedures is it's more efficient. You cannot be running, somebody cannot be sitting there and writing SQL on the terminal. You have to have things that you already know how to do. You put it in a tech case and you run it at the database level. So you in SQL Server, you do that in Truncate SQL. In Oracle, you do that in PLSQL. So there are kind of advanced SQL that are available to write stored procedures. Stored procedures are more secure. They're because it runs on the server, the security is better. It's more efficient because when you write something on the terminal or on your computer, it goes over the network and there is a latency. When you write it or run it on the server itself, it's faster. So it's more secure, it's more faster, and it is compiled, and SQL is interpretive. That means everything is done, interpretation is done when you write a SQL statement instead of Transact SQL. Those are binaries which are compiled, and they run faster. And I think that this trigger is, again, I think we talked about a stored program that is executed with the DBMS whenever a specified event occurs or a specified table or view. Like I have given an example that if you have information about buildings and apartments in two different tables, if the building has 6 apartments, if you for some reason and you are a rental company who is managing the building and you have a database where it's showing information about the building and the apartments, if the building goes away or they decide to go with some other rental company, a trigger when you delete the building from your database, it should delete all the apartments that is associated with the building, because the building, apartments without the building makes no sense. But similarly, if you are keeping track of all the pages in a book and all the information that is stored in each page, if you decide not to track that book anymore, then when you delete the book, it should delete all the pages for a book, and that's called a trigger. So this is, if something happens, something else happens. You stop subscribing to, you call up and you say, I do not want to subscribe to the Constitution anymore. So your subscription information is deleted when your customer information is deleted. So that's kind of a trigger. Again, I'm not going to get into the details. The goal is that you understand that these concepts exist, and I think we already told about stored procedures, greater security, decreased network traffic. SQL can be optimized by the DBMS. Again, today we're mostly going through concepts. Okay, so I think if we go back to the class, there are several things that are important to get on today's thing. One is that when you are creating tables, you should be able to, starting with these 3, create, alter, drop table. So you should know how to create table and how to alter table, how to drop table, how to truncate table. Again, the first 3 are more important. Insert, update, delete, and merge, those are very important. And we will talk about the outer joins in next class. But these you must practice. As I said, if you cannot do these things, you obviously cannot fully finish the project. But don't focus on the constraint as much, because that's, again, you can learn it later on and in your life. But more about create, alter, delete, drop, and those are important. The bulk update, I think that's a very important concept, how you can insert something into the database, one record at a time, and multiple records at a time with the SQL. Again, the delete, the join thing we'll talk about next class because I think I need a better design. Then talk about SQL views, SQL cursor, store procedures, and triggers. And store procedures, triggers, views, and cursor, those are basically concepts that I want you to know. Where I'm not going to put anything on the test, how to create store procedures, because these are basically beyond the scope of this class. This is basically to give you the idea that those things exist, and you must know how to do it, rather than you knowing exactly how to do it. So those are basic things in this chapter. Okay, let's see who has any questions. Again, the emphasis should be, we'll talk about outer joins. I will come up with a better example. I didn't like this example that the book had today. Basic thing is, from the physical design, you should be able to create tables. You should be able to alter tables. You should be able to drop tables. You should be able to truncate tables. You should be able to insert, update, delete, and merge tables. You should be able to bulk insert information into one table to another table. And you should know some basic things regarding store procedures, triggers, and views. That's pretty much this particular chapter. And things as I said, the things I gloss over are the things I don't think is that important, and I'm not going to ask you anything on the test on that. Okay. Anybody has any questions? Any questions? Okay, so all right. Okay, so what I'm going to do is, I will be honest with you. I think there were I know I got the last test was somewhat hard for some people. So this quiz should be relatively very easy. I made a conscious decision to give a easy quiz to all of you, knowing fully well that the final will be hard. So don't think that the final is going to be as easy as this one, but I have given an easy quiz. I'm going to send it out right now. We will, you can take 15 minutes break if you want to, and I'll give, so you'll have till 9:45 to send me the quiz. And that should be plenty time. I don't want anybody to have less time. That should be as much time as you need. So let me do this. I will send it to you guys. Email. No. Cross list. Okay.